decades, if not centuries old in places.
It's extremely inconvenient and disruptive for the customer and the community when we're digging excavations in the highways. It's extremely expensive to do that.
It's important that when we're maintaining our network and keeping it safe, that we're looking for new ways to be able to do that, because in reducing those costs, we're actually delivering value for our customers, we're delivering value for our shareholders, and we're actually improving the way that we actually operate.
The idea behind SISBot is go into the pipeline from inside through a very, very small hole in the street and work inside the pipe to seal it and to renew the pipeline's life with a minimal amount of impact on the public.
For the SISBot project, we carried out the first demonstration project in Woolwich with the larger pipelines that we have, and all the findings that we had from that, how we developed the means of connection, launch, entry, retrieval, we shared with National Grid, who then subsequently applied that to a different diameter, the 18-inch cast iron pipe within their sites.
What SISBot does is it allows us to enter the main while the gas is still on, and we can place the robot at every single joint, and using 5 cameras and the robotic mechanism, we're able to drill holes into the joint and then inject the joint with a very, very durable, long-lasting sealant.
Using the cameras, we pretty much have a 360-degree field of view. So this is the joint right here. As we're doing this, I can use the controls. I can actually see this injecting with my eyes. The length we can go currently is about 600 feet, and that allows us to go effectively 1,200 feet from one pit.
Today is unique in a way because we've got one hole and we're looking at repairing up to 50 joints. If we try to do that in more traditional ways, as a minimum that would be 50 holes in the carriageway, and today we've got one.
It's a huge benefit for safety, huge benefit for the environment, fantastic for customers just looking around here in terms of the footprint that we've got while we're on site.
SISBot is a remarkable innovation, and we've demonstrated it now on 2 different networks, and we're looking to commercialise that at the earliest opportunity. We have around 9 kilometres of gas distribution pipelines that we intend to remediate with SISBot over the next 2 years, and we're also working, very excited, on the NIC project, Network Innovation Competition project for robotics, which is to widen the robotic solution, if you like, for the entirety of large diameter mains remediation, and also look to improve the way that we do services, minimising streetworks.
Gas distribution companies were looking for methods to detect defects and blockages in their pipelines.
To be able to detect where there's a blockage in the main is something that we all struggle with. It can come from anything such as debris in the main or water ingress, which is a huge problem. So Acoustic was brought in to address issues that we have for trying to locate where the blockage is in without the need to having to excavate again.
The basic technology is simple. We use a loudspeaker to inject an acoustic signal into the pipe. We use microphones to record the reflections of that signal. What's complicated and requires research is the processing of those measurements. That's where the bulk of our research is linked with.
So here I have a 3-metre tube, and I'm going to put a blockage in it, which is a small washer. I'm going to insert the washer into the tube, then I use this magnet to move the washer down the tube. So I'm going to run it right down. Now I'm going to attach the acoustic probe to the tube and use it to fire an acoustic impulse into the tube. So that's the acoustic signal that we use, you can hear in the background. Okay, so now we can look on the computer screen and we can see here at around 1.5 metres. There's clearly a blockage.
To be able to detect blockage in the main through one single point of entry would be a huge game changer. It would mean less disruption to customers, less excavation.
Acoustic potentially gives us the option of very quickly surveying a network to ensure that it is what we expect it to be. We've all had a look at it and we've all decided that there are potential benefits in the project. So all the networks have signed onto this project.
Within the last probably 25-30 years, there's been very little advancement in the way that you detect a gas leak within the industry. So the way that it's always been done historically is to use your gas go seeker, detect the highest reading and dig down and try and locate where the leak is, which means huge disruption to the customers on difficult jobs, specifically in city centre and difficult locations. So the acoustic technology that we brought in, it's got a hydrophonic sensitive camera, and you put it on a rod down the main and it listens to the sound of gas escaping. So the idea is that you can send it 200 metres down a main through one excavation, find out the exact point where it's leaking, and then you can dig down and repair it. So it reduces the amount of excavations in the street and it reduces the disruption to customers. We didn't want to just use the acoustic camera on its own and have it just for the primarily function of locating gas escapes. We wanted to try and combine different types of technology. So we were aware that Scotia Gas Networks were trialling the Corran Vac. So what we thought we'd do is we'd combine the two technologies and have an end-to-end process.
Corran Vac is a combined, uniquely specified vehicle that does coring of the road and also vacuum excavation. It allows us to take a core from the road surface, remove it, use the vacuum excavator, basically a big hoover, suck out the spoil, effect a repair using long-handled tooling, and then put everything back as it was very quickly. So it reduces our street works from, say, 4 or 5 days, where you need to keep going back for different layers of tar, for example, to literally 4 or 5 hours for the grout to set around the core hole. We have 7 of these units in operation right across SGN, 1 in Edinburgh, 1 in Glasgow, and the rest primarily in London, where the largest amount of repair work is carried out.
The feedback amongst everybody in the business, particularly the operational guys, they absolutely love it. It makes their job a lot easier. It means they're having to do glass holes. We can go in the morning, repair everything, reinstate it and be gone by the time you come back from work without you even knowing that we've been there.
TORS basically is a method to make a service to main connection without the need for excavations. We're able to do this remotely by using our robotic platform.
For a typical section of main, let's say 100 metres long with maybe 10 services connected, you'd be looking at 22 excavations.
Effectively, we began by using an existing robotic platform that we had, and we began the task and the engineering challenge of miniaturising this.
We started with quite a rough and ready robot just to prove the principle. It was too big, it was not at the right size for the maintenance services that we wanted to target.
The greatest challenge is obviously developing a robotic platform small enough to work inside a Tier 1 pipe size. Everything is done from inside the pipe. The robot needs to be able to locate where the service enters the main. It then needs to be able to make a connection between the service and the main, and this is done by drilling a hole. We then insert a special T in order to be able to make a physical connection. Once that service connection has been made, we're then able to pressure test each individual connection before moving on to do the following connection. The next step is to turn the existing concept demonstrators into working, functional, commercial solutions.
We're hoping to get TORS into the field delivering in early 2016. When it does, I think it'll make a tremendous difference to the customers, the community, to National Grid.
Ultimately, TORS eliminates the need for digging holes. Not only the significant cost savings that this will provide, but also reduces the impact on the environment, whilst also reducing the impact on the consumer and the road users.
CIPP stands for Cured in Place Pipe, CIPP, and with this technology we can now put a felt liner up one of these massive pipes without intrusion into the carriageway. Essentially solidifies, and that becomes a new pipe within the old pipe, and we're good for 40 or 50 more years and perhaps beyond that. It's a technique that actually has been in use in the water industry for quite some time now. And what we've done as a gas industry is actually put a challenge there to the manufacturers to say, could you take this mature technology and actually convert that into something that's fit for the refurbishment of gas pipes?
Today we're going to be trialling a semi-rigid liner made of an impregnated felt, so it's got an uncured resin sitting on it. Pull that liner through, we'll inflate it so it fits snugly to the host, and then we'll cure it using heat as the cure process. Then all we've got left to do is seal that main back up. What this test will allow us to do, it'll show us two things. We'll get to understand the process of how to install the liner in a controlled condition before we do it for ourselves on a network. But we'll also be able to take these pieces of pipe away and put them through some destructive testing.
Ofgem, our regulator, are absolutely encouraging to suspend this money that they've made available to innovate. And the fact that we're actually doing it as 4 GDNs working together with WRC as a partner in something that's not been done in the UK before.